We will now look at question 9. In a nuclear power station, 30 megawatts of power is produced. So this 30 megawatts is an important information that you will be using. And in an emergency, this cold water can be circulated through the generators to absorb the 30 megawatts of power. And this cold water will eventually turn to steam as it passes through the generator. So determined by the amount of energy generated by the generators in 1 second. So from this keyword here, in a nuclear power station, 30 megawatts of power is produced. Since we know that power is equal to energy over time, or also energy is equal to power times time. Therefore, I can conclude that in this case over here, the amount of energy generated by the generators in 1 second would be 30 megawatts, which is 30 times 10 to the power 6 times 1 second. And this will simply give us 30 times 10 power 6 joules, which will be 30 times 10 power 6 joules, or you may also write it as 3 times 10 power 7 joules. Question 9b, the following information is given, and let M be the mass of the steam discharged in 1 second, and you will calculate part B in terms of M. So first part, the amount of energy absorbed by the water from 20 degrees to 100 degrees in 1 second. So if we recall our formulas that we use in this chapter of thermal properties of matter, energy Q is equal to mc times change in temperature. The mass of the water that we are looking at is simply M, given by the question. The specific heat capacity of water is given in this table, and in this case it will be 4,200. And the change in temperature from 20 degrees to 100 degrees Celsius would be the final temperature, which is 100 degrees Celsius, minus away 20 degrees Celsius. And therefore, I will obtain the answer of 336,000 M. So simply, your answer will be 336,000 M. For question 9b part 2, the amount of energy absorbed by the boiling water at 100 degrees Celsius. So over here, there is a change of state from water to the gaseous state. So therefore, the formula that we use to calculate energy absorbed will be Q equals to the mass of water times the specific latent heat of vaporization. So if we look at this table over here, we can see that the specific latent heat of vaporization will be 2,250, and important fact that over here this is in kilojoules, so therefore this will be 2,250,000 joules, and therefore my answer will be 2,250,000 M. Okay. And for B part 3, similarly, it's the energy absorbed by the steam to turn it from 100 degrees Celsius to 200 degrees Celsius. So it's similar to part I. The energy will be M times specific capacity of the steam times change in temperature. So this is simply M times 2,000 times final temperature 200 degrees Celsius minus initial temperature 100 degrees Celsius. And from here we'll get the final answer, which is 200,000 M. Okay. So therefore the answer for question 9b part 4, okay, therefore determine the minimum volume of water required in 1 second in an emergency. So we know from question 9a is that in 1 second, the amount of the energy generated by the generator is this amount over here. And in order for the water to determine the amount of water required, we know that we have to get an amount of water required which can help us get rid of this amount of energy over here. Okay, so to find the mass, we can form an equation. the total energy absorbed from part B to turn the water from 20 degrees Celsius all the way to steam at 200 degrees Celsius would be equal to 336,000 M plus 2,250,000 M plus 200,000 M. And this is equal to, from earlier 9a, 30 times 10 power 6. So therefore, I can easily calculate from here that M is simply equal to 10.7661. Okay, I'll write it in 6 significant figures first because this is not my final answer. And from there, I will be able to recall that by the density mass volume formula, minimum volume will be equals to the mass of water required over the density of water, which is equal to 10.7661 over 1000, which is obtained from the table above. 1000 kg per meter cube. Okay, so therefore my final answer to this question, the volume of water required will be simply equal to 0.011 meter cube in 2SF. And this will be all for question 9.